Okay, so in this last video, we talked about a new technique called reduction of order, and we can put that in our toolbox. The idea is that you're um, given one solution to given one solution to a second order linear homogeneous differential equation. We can find a second. And of course we have this other technique here, right, as well, and that is find the Wronski in two different ways. Good, so don't forget that those are part of this chapter, because now we're going to summarize how to solve the second order differential equation. I'm going to pause and write down the summary. Okay, so we're solving ay double prime plus by prime plus cy equals 0. Our ansatz was y equals e to the rt. And from that we got the characteristic equation, which is a quadratic. And from that we get using the quadratic formula, we look at the discriminant. And if the discriminant is positive, then r1 and r2 are distinct and real. And so we get that y equals c1 e to the r1t plus c2 e to the r2t. Right? E to the r1t and e to the r2t form a fundamental set of solutions. Good. Case 2 is the complex case. B squared minus 4ac is less than 0. And so therefore we can write the r as alpha plus or minus beta I. And you'll notice that we only use one of these, right? Because, well, we talked about that before. So I usually just write the alpha plus beta I. You could use alpha minus beta I as well. And so the idea is that this general solution then is down here. You could factor out the e to the alpha t, and then we would have c1 cosine beta t plus c2 sine beta t. Now you might remember, right, that what we're really saying here is that y is equal to c1 times the real part of e to the rt plus c2 times the imaginary part of e to the rt. Okay, so that's another way to remember it. And the last case is what we just did. B squared minus 4ac equals 0. Our second solution is t e to the r1t, because we only have one r. I guess I didn't need r1, I could just write r. And you could factor out the e to the rt, and so you would be left with c1 plus c2t there. Good. So now we'll just try a few exercises. So let's solve 4y double prime plus 4y prime plus y equals 0. Okay, you might pause this if you want to go ahead and work through it on your own. Otherwise we will just continue on. Write down your characteristic equation. Right, and we need to solve that differential equation, or sorry, quadratic. And so I would go ahead and divide by 4 first, and so we would have r squared plus r plus 1/4. Okay. Let's see. Is that to solve this, you could try to get a perfect square. So what's the half the middle term squared would be 1/2 squared is 1/4. Oh, this is already a perfect square. So this is r plus 1/2 quantity squared equals 0. Right, so that means that r is equal to minus 1/2 minus 1/2. And so this is the case where b squared minus 4ac equals 0. We only have one real solution. So therefore you can, if you want to write your two solutions, right, it's going to be e to the minus t over 2, and then y2 is t e to the minus t over 2. And the general solution, right, would be e to the t minus t over 2 minus c1 plus c2t. Very good. Okay, solve. How about y double prime plus 4y prime plus 13 equals 0. Again, feel free to pause if you want to try it out on your own first. Okay, otherwise we will continue. Let's see, I'm going to go ahead and complete the square on this one. Good. So it's going to be a 2 squared equals minus 9, and so that gives us our complex number there. R will be minus 2 plus or minus 3i, and so therefore the solution is e to the minus 2t times c1 cosine 3t plus c2 sine 3t. Did you get that one? All right. How about one more? Two more, maybe. So 3. How about y double prime plus y prime minus 2y equals 0. So again, pause if you want to try to solve that on your own. Okay, otherwise we continue. Complete the square. Oh, wait a minute. I don't need to complete the square. That factors. What is it? Factor plus 2 and minus 1. Good. Good. So our general solution will be e to the t plus c2 e to the minus 2t. Very good. All right. Okay, let's try one more exercise or one more example, and this time I'm not going to solve. I'm going to see if you can remember your reduction of order. And so we'll do an example of that. Suppose I've got the differential equation t squared y double prime minus 4t times y prime plus 6y equals 0, and I know that y1 is equal to t squared. Can we use reduction of order to find the second solution? Do you remember what it is? Reduction of order is to assume that your second solution is v of t times y1 of t. So in this case that would be t squared times v of t. And then you plug this into your differential equation and see what you get. Okay, so let's see how's that going to work. I'm going to have t squared, and then the second derivative, well, okay, let's get some space here. Okay, let's see, my first derivative will be, let's see, 2tv plus t squared v prime, and then the second derivative, t squared v double prime plus 4tv prime plus 2v. Okay, so you might take a moment to compute those just to verify. Good. And if you simplify this whole thing, I believe we will get t to the fourth v double prime equals 0, or v double prime equals 0, or v prime is equal to a constant, or v equals one constant, and then we get the second constant. So what's the interpretation of that? Well, that means that y2 is equal to c1t plus c2 times t squared, right? And so if you multiply that out, you get c1t cubed plus c2t squared. Now this part is actually already taken into account in y1, right? Because y1 is t squared. And so if you're just looking for a pair of fundamental solutions, for a fundamental set of solutions, you don't need to include this piece or the constant. I would just say that y2 is equal to t cubed. Good. And so that is the method of reduction of order. All right. So try out a few of the exercises in the book. There are some that will use Maple. I may do a video with Maple or Mathematica or Wolfram Alpha. Well, give them a try. See you in the next video.